Question number 1. Einstein-Rosen bridge is a hypothetical description of which of the following? Option A, black hole. Option B, white hole. Option C, wormhole. Option D, Star Trek. Question number 2. Wormholes are consistent with which of the following theories? Option A, general theory of relativity. Option B, special theory of relativity. Option C, Newtonian mechanics. Option D, Doppler effect. Question number 3. Consider the following statements. Statement 1. Scientists have created holographic wormhole. Statement 2. They have used the principles of quantum computer and a sycamore processor for this purpose. Which of the above statements is or are correct? Statement 1 alone, statement 2 alone, both 1 and 2, and neither 1 nor 2. To find the answers for these questions, let us discuss the concept of wormhole. Wormholes are also known as Einstein-Rosen bridge or ER bridge, representing or denoting or honoring Albert Einstein and Nathan Rosen. For the first time, the term wormhole was coined by John A. Wheeler in 1957 in his paper that he wrote with his fellow scientist Charles Misner. In simple words, what do we understand by the term wormhole? Wormholes are shortcut tunnels for the long travels or long journeys through space-time. To understand it in layman terms, if we can take an analogy, take a sheet of paper and consider that paper or imagine that paper as a plain space-time continuum. And there are two distant points on that sheet of paper, let's say point A and point B. These are the two distant points to be traveled through space-time. If we travel outside the wormhole between these 2 points, it takes a very long time. However, if the space-time is bent, for example, in our example, we have taken a sheet of paper as a plain space-time, and if it bends such a way that these 2 points come closer, point A and point B come closer, the distance between these 2 points is heavily reduced. So the time taken to travel between these 2 points is reduced, and this is how wormholes reduces distance between 2 points in space-time continuum. We have different types of wormholes: traverse wormholes, non-traverse wormholes. Traverse wormholes are the wormholes wherein we can travel. In our example, from point A to point B, we can travel. Even there are 2 types, like one-way travel and two-way travels. Let's say if we go from point A to point B and there is no way to come back, that's one-way travel, one-way traverse wormhole. Or if we can go to point A to point B and come back from point B to point A, then two-way traverse wormhole. The other type is non-traverse wormhole, wherein they don't allow further travel. And we do have inter-universe wormhole, intra-universe wormhole. Intra-universe wormhole is that we travel within the universe. In our example, we have taken 2 points A and B. Those 2 points are well within our universe. So those type of wormholes are known as intra-universe wormhole or intergalactic wormholes or any other. Like let's say if those 2 points are A is in one galaxy and point B is in other galaxy, we may call it as intergalaxy wormholes. Okay, and there are other type which are described as inter-universe. That's, let's say, the one point, that's point A is in our universe, point B is in the other universe. Let's for some time assume that there are more than one universe based on the concept of string theory and the other principles. And wormholes connect one universe to the other. Point A in one universe, our universe, point B, the other universe. These type of wormholes are known as inter-universe wormholes. Our mathematics predicted the existence of wormholes. In fact, these wormholes are consistent with Einstein field equations. The solutions of Einstein field equations prove us or support us for the existence of wormholes with 2 mouths, and both the sides, these mouths are black holes. We may consider one mouth as the black hole and the other mouth as white hole. Although mathematics predicts for the existence of wormholes, we do not have substantial experimental evidence for the existence of wormhole. In 2022, a team led by Maria Shiropula of California Institute of Technology have created holographic wormholes. They have used a quantum computer. Of course, it is a debatable concept whether it was really a quantum computer, have they achieved a quantum supremacy or not. But okay, for our understanding, it's one of the best standards of computer, or to a certain extent we may call it as a quantum computer. Okay, they have used quantum computer and created these holographic wormholes, and Sycamore processor was used for this purpose. This processor was built by Google's artificial intelligence wing or artificial intelligence division developed this Sycamore processor, and it has 53 qubits. This is about a trivia about this system. Okay, although this is not a giant step, but definitely we can call this as a tiny baby step towards finding out the existence of wormholes. Does it help us to travel faster than light? Yes, in a way, yes. Suppose if we travel through wormholes and the light beam travels outside of the wormhole between those 2 points A and B in the space-time, we travel faster than light. That's like if we travel through wormhole, the time taken for us is less than for a light beam to travel. If light is allowed to travel in the wormhole and we are allowed to travel at the same time, definitely light beam beats us. The light definitely travels faster than we travel. One of the theoretical physicists I think Stephen Chu stated once that wormholes are not the means of time travel. Wormholes reduce the distance between 2 points in space-time. It helps us to reach faster, but not help us to travel in time. Wormholes are considered not stable. That's one of the main issues with wormholes, is the stability. If you have to make these wormholes stable, we need exotic matter which we are yet to familiarize with, and there are some physicists who say that it's slightly dangerous, and there are some other physicists who say this produces a lot of radiation, right? And there are some other physicists and scholars who opine that laws of physics do not permit us to travel through wormholes. However, let us be optimistic and hope that soon our physicists, our scientists find out the existence of wormholes, and also find out an intergalactic travel within our lifespan itself. Thank you.